I want to go through the solutions for exam number 1. Hopefully you can use this as a review. We'll see more problems like some of these going forward on exam 2 and exam 3. So hopefully this will be helpful for you going forward. So question number 1 on exam number 1, right, has to do with automation of job functions. AI, machine learning, etc. Is good or bad for the economy and for workers and employment? This is very much the same question we had as one of the homework questions. And we need to use graphs of the production function, labor market to do the explanation. So let's just go right into that. So if I'm drawing the production function, right, y is a times k to the 0.3, n to the 0.7. There's GDP, employment, and then we want to use the labor market. The same n is on the axes here, but the real wage is on the vertical axis. Labor demand, labor supply. That determines the equilibrium wage to begin with, and the equilibrium level of employment. We call it full employment, right? Equilibrium in the labor market. Remember, this is the long run, not business cycles, but over long periods of time, decades, maybe even centuries, but let's say years, decades, right? And we take that level of employment up, straight up, right? And we find with that level of employment, this level of capital and technology and total factor productivity, we get this much real GDP. We call potential GDP or full employment level of GDP. So this is our starting point. Let's label that with an A, those equilibrium points. And then the question is, what happens? So which markets, what happens? So something happens, which market, which curves, which way, and then summarizing what happens. So with an increase in technology, we'll do it with a different color here. That is like an increase in A, right? So let's call it an increase in A. That shifts the production function up, right? This A right here, and the production function. It shifts the production function up and makes the slope steeper at every n, level of n, the marginal product of labor, in other words, that leads to an increase in, right, due to an increase in A, increase in the marginal product of labor. So in the end, what do we have? We've got an increase in employment, more employment than we did before, an increase in the real wage, with that increase in level of employment, and more productive labor, because now it's got new technology to work with, all right? It's on the new production function, so let's just extend this one. All right, we get a boost in real GDP. So real GDP is increased, employment's increased, the real wage is increased. So question, remember that we're asking, is it good for the economy? All right. Good for workers? So we're always using our model to answer this question. So not what we think or just sort of generally, but what does the model tell us, right? So according to the model, which is these graphs, the labor market, the production function, right? Is it good for workers? Well, real GDP is up, so that's good. Employment is up overall, right? That's good. The real wage that workers get overall, on average, is up. So the answer is yes. Is it unequivocally good, right? Is it good for everyone? Well, that's really the second part of the question. So this is part A. So part B really is getting at the question, is it good for everyone? And if not, who's going to be disproportionately impacted? So we read a piece. Let me share that. One of the pieces that we read, I'm not sure what's actually showing here. It should show. is a piece about race and jobs at risk of being automated in the age of COVID-19. So if we scroll down through that, right, early on in that piece, right, it talks about the impact of COVID-19 and the disproportionate impact of COVID-19 on different groups of workers, in particular by race. And then it relates that to what's expected to happen in terms of automation going forward in the wake of COVID-19. And then the question becomes, well, all right, who's most likely to be affected by that? So there's a set of questions that in the first part of this in the introduction, which occupations are most and least susceptible to automation in the next 2 decades? And in particular, how will developments in automation affect Black and Hispanic communities and institutions, right? So what we see here, right, is that, and the argument in the way that they go through this, right, is to say, look at what are the percentages of Blacks and Latinos, Hispanics in jobs that are most likely to be replaced by automation going forward, and the least likely. And so the summary is really in this paragraph, in a sense. Both advances in automation and the economic impact of COVID-19 pandemic disproportionately affect Black and Latino workers. These workers are more likely to be employed in jobs that are at high risk of being automated in the next 2 decades, and that cannot be done remotely. Okay, that is really the key. So it's not about, in this case, discrimination. Next, it could be about systemic racism that led these different groups to be in those particular occupations over long periods of time, in history, for various reasons. But right now, the question is, what's likely to happen just from the data? And they go through a bunch of data series, right? They go through different graphs and talk about that, right? The 30 jobs at the highest automation risk and that have the highest number of workers, and then the different percentages by Blacks and whites and by Asians, Hispanics, etc., and go from there, right? And so, yes, more likely to be impacted. And what's the value? And they talk about this at the end in terms of interventions. So what can HBCUs do? Why are HBCUs particularly important, we might argue, in this role? And so they actually talk about that. And they talk about HBCUs because they disproportionately, right, impact Blacks and Hispanics, minority serving institutions, HBCUs with Blacks and minority serving institutions, MSIs, which include Hispanic serving institutions as well, are particularly focused on educating at a higher level in terms of college level degrees, workers in those respective ethnicities, and providing the kinds of educational tools that are likely to put them in jobs that are less likely to be automated. So from a policy perspective, right, not only within HBCUs, focusing on people actually being retained and graduating, but from a society standpoint, more and continued and more support for HBCUs, because they do a disproportionately good job at educating, in particular at HBCUs, Black students. So that is the answer to that first question. Right. Now, question number 2 talks about, we'll go back over to the screen again and do some writing. Okay. So, hold on just a moment. That's an issue here. problems here. There we go. All right, let's go back to the iPad and look at question number 2. So we want to get, so from part A, we want to get from the production function to per capita real GDP, right? So Y divided by population. We do that, we divide both sides. We have A, K to the 0.3, N to the 0.7 divided by the population. So we've got A, K to the 0.3. And then if we and then N to the 0.7. And if we multiply both sides, or this side, sorry, N over N, which is 1 by 1, times 1 over the population, then we have A to the K to the 0.3, N to the 0.7, N to the 0.3, times N over pop. Oops, not N to the 0.3, N to the 1, sorry. That's what we're going to end up, but sorry about that. N to the 1, and this is equal to A times K to the 0.3, N to the minus 0.3, there we go, times N over pop, or A K divided by N, capital per worker, to the 0.3 times N over pop, which is what we're trying to get to, right? So we can derive that directly from the production function, right? So real GDP per person in the economy is represented by that equation. Now, if we use this part B, right? If we use this to measure how well off people in a country are, it says, why are some countries rich and why are some countries poor? In other words, why are some countries, that's a big number here, this is a big number, and why is it a small number in other countries? Well, the sort of quick answer to that is, it's either because A, rich countries are rich either because A, K over N, or N over pop, which is the labor force participation rate, right, is larger than in countries that are poor. So one or more of those are big. I mean, that's the sort of the simple answer to that. It's just getting you to think about that. All right. So rich countries, A, K over N, and or the labor force participation rate are large. And it can be some trade-off between them. One country could have a high A, low and low labor participation rate, and could end up being richer than a country that has a high labor force participation rate and a low level of total factor productivity, A. All right. So, a poor country, then A, capital per worker, and or the labor force participation rate are low, small. So that's really the answer to that based on that equation. So then it says part C, why is it that increases in total factor productivity, A, right, are key, right? So why is it that A is the thing that matters most, right, for increasing real GDP per person long term? Okay. So first of all, it says, what do we mean by A? A is total factor productivity. That's the name of it. So what does it do? It's a multiplier, essentially. For any level of capital per worker or labor force participation rate, it multiplies and magnifies that value of that capital in terms of production, or workers in terms of production. Right? So it includes things like education, includes things like technology, ways that people organized work. Back in the early 1900s, Henry Ford and the production line, for example, right? Those are just a different way of organizing work. All of those things were enhancers to the amount of capital and workers that were working, right? So why is A the thing that matters most? And so the short answer to that is Kn to the 0.3 exhibits diminishing returns. The bigger that gets, right, the bigger Y over pop gets, right, per output per person, but it gets bigger at a smaller and smaller rate because of this 0.3 exponent. And so at some point, there's a limit to how much capital per worker can expand production, right? So if you get, at some point, there's just too much capital for each worker, and it doesn't really increase output that much more as nothing else is changing, A, or labor force participation rate. In terms of N over the population, the labor force participation rate, this has to be less or equal to 1. The biggest it can be is 1. So it has a limit. It has a limit as well. Okay. In terms of the aggregate production function, which is asked for here, right? So you can think, if we have N on this axis and Y on this axis, you can think about N over the labor force participation rate as N is getting bigger, employment's getting bigger, okay, for a given population. So we're moving out here, we're moving along the line. So as you get more and more, it gets bigger, but at some point that has a limit. What we're saying is K increases. As K increases, this shifts up. But as K increases more capital per worker, as it increases more and more, the changes and impacts on GDP get smaller. All right, so increase K some more, increase K some more, and you get less and less of an impact on real GDP, right? Those changes get smaller. The distance between these gets smaller as we go forward. Okay, that's what it means in terms of the production function. So now part D actually look at US, is actually to look at US data, not just theoretically like in the parts above and parts B and C, but what does US data say? This goes back to the Congressional Budget Office data that we looked at as one of the homework questions. And what we see is that in particular, labor force growth in particular is slowing in the future. At least that's the projected trend in the United States, right? So the percent change in N, right, is getting smaller. And so if we have the growth accounting equation, we could use that, or we can think about it in terms of the equation that we had above, right? This component of the growth in the production function, right? If we look up here, right? So N up here, right? That is growing, but it's growing at a smaller rate, right? So from the growth accounting equation, we have the percent change in Y is equal to the percent change in A plus 0.7 times the percent change in K plus, 0.3 times that, sorry, plus 0.7 times the percent change in N. We're talking about that. So that will increase. I'm not talking about it actually declining. It could decline if the population actually declines at some point in the future, but over the next decade, it's just getting smaller. And so the growth of Y is going to get smaller unless what? Unless one of these two things increases, right? Those are projected not to be increasing either, but that's what would be needed in order to that's what will be needed in order to keep the economy growing at levels that it was previously. Okay. So living standards will increase, but at a slower rate if those trends are actually hold out to be true. Right. So why is it that part E is why some relatively poor countries catch up to richer countries and even surpass them over long periods of time, like a century, while some relatively richer countries fall in their relative rankings. Okay. In that case, it's got to be, we got to go back to the equation, right? It's that growth in real GDP is growing faster in some country than in another one. It could be a poorer country. If the real GDP per person is growing faster than in the larger country, then it's going to catch up eventually, right? The rule of 70, if the growth rate's faster, it doesn't take as many years for real GDP to double. And so we can actually see that over time, that because it takes a short period of time, over 70 years, maybe it doubles once in a country that's not growing fast, but it doubles twice, let's say, in a country that's that's growing fast and doesn't grow double, only doubles in once in a country that's growing more slowly. So ultimately, it can catch up and even surpass. How can that be? Well, either the changes in A, capital per worker, or the labor force participation rate are growing faster in the country that is experiencing higher real GDP per person, right? So that is ultimately related to becoming a rich country, right? If those are growing faster than in other countries, even though those other countries may be at a higher level of real GDP now, that at some point, because of the higher growth, the poorer country can catch up and surpass that country in terms of the level if its growth rate is higher. Okay? So that's question number 2. Question number 3 has to do with these long-term trends related to labor in the U.S. And there's a quote from Wall Street Journal article saying total employment is going to grow about 0.3% till 2032. So it's kind of related to this question number 2 as well. Much slower than the 1.2% over the past decade. So labor force is going to grow more slowly, right? And because baby boomers in particular retiring, also birth rates are slowing down and maybe even will go negative at some point. So what's the predicted impact of these trends on employment, real wages, real GDP in the economy over time? So use their production function, labor market, again, like in question number 1. So let's draw that. So here's y equals a times k to the 0.3, n to the 0.7. The level of real GDP, employment, right, on the horizontal axis, real wage here, labor demand, labor supply. Again, we start out in equilibrium. This is the equilibrium level of employment. Here's the equilibrium level of real GDP, full employment GDP, for a given level of capital and a given level of total factor productivity, A. So again, let's just label those with an A. That's our starting point. So how would we model this slowdown in the growth of the labor supply? Well, we could show it in terms of the, so there's sort of 2 ways that you can think about this. I'm willing to accept both of those for full credit. It could be how fast labor supply has increased in the past, how far it shifted to the right versus how far it shifted projected to shift to the right currently over the next decade. We could also think about it in terms of a leftward shift in labor supply. That's really if it actually declines. That's not what the article is saying. It's actually talking about a slowdown in the growth rate of labor supply. So I'm going to do that one. But if you actually have it shifting to the left, labor supply increasing, I accept that too with for full credit, and it will get the same idea. So let's just work this through. So we could think about over time. So historically, let's say it would have gone out this far because of population growth, etc. Labor force participation rate being high. So let's say that's historically what would have happened. So if labor supply continued growing at the rate it had been, the 1.1% a year, I believe it was, we would expect, let's just call this historical, we would expect real GDP to be this big in the future. But instead, if we're saying, oh, no, labor supply is not really going to go that far, but only this far, right? This is the labor supply. This is the actually what's going to happen. Then we'd say, well, then employment's only going to be here. It'll still be bigger than it is now, but not as big as it would have been. So this is N2. Bring this up. Alt C. Then real GDP is only going to be here. It will only have risen this much rather than that much. Right? Employment will have only increased in 2 rather than in 1. Okay. So what we see from that, right? What's the predicted impact of these trends on impact on real wages, etc. You can see in terms of real wages would end up being higher. That's not necessarily surprising, right? Because if labor supply is not increasing as fast, then there aren't as many workers as there would have been for the jobs that are there. So there's more competition. Firms are going to have to pay higher wages. So workers are likely to get higher wages. Just like now, when there haven't been as many workers post-pandemic, wages have gone up because firms are having more challenges finding workers, restaurants, hotels, etc. So we would see that the actual level of real wage would be higher than it would have been had labor supply been growing at its historical rate. But we see that real GDP is not growing as high as it would. So the growth rate of real GDP is not likely to be as high, holding everything else constant, right? And so part B is getting at that holding everything else constant. What would need to happen if for real GDP to continue growing? So instead of being at Y2, what would cause it to get up to YA? Well, this would have to shift up so that we could, even with the lower level of employment, we could still get a higher level of real GDP. So what might that come from? Well, an increase in A in particular. All right, so technology increasing and shifting the production function up, right? So this is an increase in A, increase in technology. Again, this is related to question number 1 in a sense, right? Is increase in technology, AI, good for the economy or not? It could also be that instead of shifting the production function up, if we wanted to get the labor supply curve out where it was, right? Historically, what might we do? Well, if we could get more workers into the country, we could increase immigration, right? That would be another way to, that case would get to B, even though domestically we wouldn't have enough workers to do that if the labor force isn't growing as fast internally. So an increase in immigration could also get us there, all right? Or some combination of those two, right? Increase in birth rates would do that as well, but that's already taken into account in that projection. So that is question number 3. So question number 4 on the homework has to do with the uses of saving identity. All right. Again, from one of our homeworks. All right. So private saving plus government saving equals investment plus the current account. Right. And the stem of this question says there have been tax cuts, increases in government spending, increases in the budget deficit. That has to do with the saving by the government. And the assumption is that that is going down, continuing to go down. All right, so the question is, given that, why could this be bad for the economy overall? And why isn't it necessarily bad for the economy? All right, so let's talk about the first part. Why might it be bad? Well, if private saving doesn't change, the current account doesn't change, there's an equal sign here, right? There's an equal sign here. So if something on the left side of the equal sign goes down, then something's got to go down on the left side, or something else got to go up on the right side. But if we're saying that nothing's going up on the right side, that could lead to investment going down, and that means less capital. And we know from the production function, less capital, that means less real GDP. Okay, so that could slow down growth, slow down real GDP growth. But that's not necessarily the outcome that would happen from the increase in the budget deficit or a decline in government saving. Okay, so instead of that happening, it could be that that goes down and investment doesn't change at all, right? It just stays where it is. So could be CA goes down instead. What's that? That's the current account. It's our trade deficit or trade surplus. It's trade surplus if it's positive, or deficit if it's negative. We generally run a trade deficit, so that's a bigger negative, it's a bigger trade deficit. So the trade deficit could go up instead, right? It's a deficit, bigger negative number, so that's why it's up, right? And what that means is the government is essentially borrowing from other countries. So the government runs a budget deficit, it has to borrow more. You can borrow more either from within the country, from internal savers, okay? Which leaves less for investment, right? In that case, that's like the bad outcome, all right? In chapter 4, we'll find out that that leads to higher interest rates, which is what leads to less investment. But it could also lead to an increase in the trade deficit, right? It's borrowing more. And so instead, it could be borrowing from other countries. If we're running bigger trade deficits, it means more dollars are going out of the US to buy stuff from other countries than are coming back to buy our stuff. That's what it means to have a trade deficit. And what foreign countries want to do with those dollars is they want to not just hold on to them, but they want to earn some return on them. And so what they do is they'll buy treasury bonds, treasury securities in the US that are being issued by the government when they run their budget deficits. So the question then becomes, so we owe that money in that case to foreign citizens, but if it allows the investment to continue at the same level, or maybe it could actually even go up, right? If the trade deficit increase is big enough, and if that is put into use for new infrastructure, for example, that shifts the production function, increases real GDP growth, it may be that borrowing is worth it. in exactly the same way that you're borrowing for college can be worth it in terms of higher growth in your income in the future, where you can pay off the debt that you have incurred, right, to go to college, and still be way ahead compared to if you had not borrowed, not gone to college, and gotten a lower level of income. So the uses of saving identity can be really helpful to us in understanding that. Okay. All right. So we've kind of answered part B here as well, based on your answer. How could increased budget deficits affect the economy in the long run? So they could affect investment in new capital, and that would have a negative impact on real GDP growth in the future. Again, does it matter whether the deficits are caused by a reduction in taxes or an increase in government spending on infrastructure? We hinted at that when I was just saying that before. If a reduction in taxes is what generates the budget deficit, it depends what that reduction in taxes was used for by consumers, but probably on increased consumption. Whereas if the budget deficit increase was caused by spending on, say, infrastructure, that is going to boost productivity in the economy in the long term, then it's likely to raise the level of real GDP growth from that increase in A, increase in K, again, going back to the production function. So yes, it depends what the tuition, or sorry, what the budget deficit comes from, and what the spending is on. Okay. So again, in that case, it says if you look at you're asked to think about the production function, right, and y, right? So in case of the budget deficit, from an increase in decrease in taxes, right, where there's no change in the production function, then this is not going to change, right? So for a given level of employment, it's not really going to have an impact in that case on long run real GDP. So we just stay right there in the long run. If the budget deficit increase was caused by an increase in spending on infrastructure, that's increasing A or K from the public side, from the government side, then that is likely to lead to, right, an increase in, and actually probably if we brought the labor market in here, it would also increase employment. We get a double boost, more employment, more productive employment, right? And so you increase the ability to pay off the higher debt in that case. It depends whether you have spent the money on something that adds to your productive capacity, your income in the future, your real GDP in the future, or whether it's just a redistribution to consumers from the government that doesn't necessarily lead to higher levels of real GDP in the future. If the lower taxes end up in the pocketbooks of consumers, and they use that to pay tuition to go to college, and they otherwise wouldn't have done that, well, that can have the same kind of impact, right? But the increase in infrastructure does that directly, right? So it depends on what you spend the money on. In chapter 4, we'll be looking at exactly that. Okay. It's also the case up here with the production function. If there's a tax cut and that's what causes government spending to go, government savings, to go down, the increase in the budget deficit. And if consumers save that money, increase that, well, then there's not necessarily any decline in investment either. There's more saving in the economy on the private sector. Interest rates, ultimately, we're going to get to that in chapter 4, wouldn't be affected in that case, and there's no impact on investment either. So again, it depends what people do, even in that case, with a tax cut, with the money that they get. All right. So, and then finally, question number 5. Question number 5 is a table of data. That's part B. Part A has to do with the work, the reading that we did by Dr. Lisa Cook and the discussion board question that you had from her. Right? And so the idea is, and we go back to the production function again, right? K to the 0.3, N to the 0.7, or the growth accounting equation, the percent change in real GDP, percent change in A plus 0.3 times the percent change in K plus 0.7 times the percent change in N, right? So what she's getting at in this racial violence research paper that she did is to think about patenting and the impact of, it's a very novel way of thinking about this, the impact of racial violence on patent production, and patent production in particular being tied to A. Now, the racial violence may have impacts on N as well, right, in terms of workers, but her real focus really in this paper was on the impact on intellectual property, on the advancement of new ideas, new technologies, etc. And the idea is that patent production by Blacks, or approvals by Blacks, right, was slowed down, right, during the period in the early 1900s, late 1800s, early 1900s, and that caused the growth rate of A, or A itself, to go down. So, and if we add on any impacts by on labor as well, right, that's only going to add to that, right? So if racial violence causes A to go down, N to go down, then the percent change in Y, the growth rate of real GDP, is going to slow down. Okay, so it causes A to go down, N to go down from what it would have been had there not been the racial violence. Just kind of doing a what if kind of scenario, right? And say, what if those patents had been continued to be produced at the level that they had previously? That's another way to think about this. Real GDP would not slow down, and we'd have higher levels of real GDP, right, for everyone in the economy. And that's really the last part of this question, part A, which was also part of the direct discussion board question as well. Why is it good for everyone? The idea here, what she's really pointing out, is that real GDP for the whole economy is larger, right? And we get that directly from these two equations, in particular the growth accounting equation. But either one of these, we'll get to that same idea. And so real GDP would be higher without the racial violence and discrimination, etc. So it's an argument for putting effort into reducing that racial violence, reducing discrimination, because it really does improve everybody's lives to higher real GDP, not just for those that are directly impacted by the racial violence and by the discrimination, but for everybody in society through a higher level of GDP, higher growth rates in the economy. Part B does provide this table where it's got two different years, right? Year A, B, got GDP price index for both years, nominal GDP, and the population. And then the question is, and so given the numbers, right, here, is the economy, what's happening in this economy? What's happening to the individual standard of living in this economy based on the data? So we can't really tell that directly from here. We've got to do some calculating, right? So first of all, we need to calculate real GDP, right, which is the GDP price index. divided by the, I'm sorry, I've got that reversed. Let's erase that. Sorry. Is nominal GDP divided by the GDP price index. And this whole thing times 100. And then we're not quite, if you do that and you actually do the calculations using for each year, what you'll find out is that the real GDP in both years turns out to be 191 461 41. That's real GDP, right? In both years. So 19, right? This is in real GDP overall. So 19,146,141 in both years. So there's been no change in real GDP from year A to year B if we look at the total size of the economy. But the population's grown, right? If you look at the actual numbers in the question, right, the population has grown from year A to year B. And so what we need to do is we need to take this number divided by the population, right? This is like the Y over pop, right, from the earlier questions on the exam. And if we do that, we multiply that by 100, what we find out is that the real GDP per capita, and that's, remember, what we're really interested in terms of measuring standards of living. In year A, it turns out to be 57,686. And in year B, it turns out to be 57,115. So what you can see is that in year A, the real GDP per capita or per person is higher than in year B. So real GDP per capita is actually going down. And so the average standard of living in this economy is going down from year A to year B. Okay. And question number 6 is meant to have you talk about the journaling that you're doing in terms of the macroeconomic indicators and to provide an overview of the state of the economy at this point in time, or at the point in time of the exam. And so we'll be talking about what's happened to real GDP, what's happening to employment, the unemployment rate, labor force participation rate, the inflation rate, what happened to the Federal Reserve, right? It's really meant to be a summary of the kinds of things that you're doing your macroeconomic indicator journaling about during the month. So it's to be accountable for that. So the quality of and completeness of your response to that question, if you completed that question, it determined your score for that. What you should see overall from this exam, right? If I was just going to, it's something I tell you all up front and tell every semester, right? Is that, it's directly related to homework questions. The past exam questions. Similar. So if you looked at those and worked your way through those, also the review questions, discussion board, right? Questions. In this case, the macro indicators journaling. In other words, all of the things that we've been doing in class are directly related to what was on the exam. Okay, so when I think about these related to homework questions in the future, I really encourage you look at the homework solutions as a study tool, not as the only thing that you look at, but that's a way to really get insight on how do I answer these questions completely and fully in order to maximize the number of points. So there were 115 total points on the exam. You could have left, for example, question number 6 blank and still gotten 105 points. So it was a variety of scores on the exam. The top score was over 100. But there were a variety of scores throughout that. Future exams will look similar to this. We'll have more points on it than you can get more than 100% on an exam. But you'll need to really make sure that you understand the different pieces that go into that exam based on the content that since the previous exam. So I hope that going through this has helped a bit and will help you going forward into the future.